All right. Good afternoon. I hope we are good. I hope we're good. So, in this video, I'll be teaching you physical sciences, paper one. And then the topic that I'll be focusing on, it will be energy. I'll be teaching you about energy. This is what we'll be looking at, energy. All right. Now, what is energy? What do you know about energy? What is energy? Energy is the ability, energy is the ability to do work. Energy is the ability to do work. And then what do you know about energy? It's SI unit is joules. Energy is measured in what? In joules. That's what we know about energy. And then another thing is that energy is a scalar, it's a scalar quantity. That is energy. It's a scalar what? It's a scalar quantity. Right? Now, we have two types of energy that we're going to talk about. We're going to talk about two types of energy that we're going to talk about. What are those two types of energy? We have what we call gravitational potential energy. We have what we call gravitational potential energy. And then what is this? What is this? The energy that an object, the energy that an object has due due to due to its position, due to its position in the gravitational field. Field relative to a reference, relative to a reference point. You can use the examination guideline. But basically, when we talk about gravitational potential energy, we are talking about an energy that an object has due to its position in the gravitational field relative to a reference point. Okay, let's come to the second one. We talk about chi. All right, maybe I can just move slowly so that you see what is happening. Okay. Now, the formula for gravitational potential energy, it's EP, it's known by EP is equal to mgh. You see, that is what we have. All right, the second one, we talk about kinetic energy. We talk about what? Kinetic energy. Kinetic energy refer to what? The energy that an object has. Object has due to its motion. Because of the motion. This has something to do with motion. This has something to do with position. See? And then what is the formula for this? It's EK. EK is equal to 1 over 2 mv squared. 1 over 2 mv squared. All right, what does this G stand for, Bananga? It's 9.8 meter per second squared. Every time when you calculate this, you use 9,8. You see? That is what you need to be using. And then M stand for mass. M stand for what? Mass in kg. It should be in kg, the mass. And then V, it's velocity in meter per second. Yeah, meter per second. And then H, it's height. I mean, on the potential energy, height in meters. So meaning that if it's in centimeters, you convert it to meters. If it's in gram, you convert it to kg. Those are the things that you need to do, grade 10 learners. See, let's have some few examples so that we can see where we are going. Let's just see where we are going. Okay. Now that's it about the kinetic energy and the potential gravitational potential energy. Okay, let's have this as an example to see if ever you are with us. Okay, here's the simple question. Determine the gravitational potential energy. Gravitational potential energy of a 300-gram ball when it is placed on the chair, which is 2 meters high. Okay, look at this one. Simple example. Calculate the gravitational potential energy. Now you just come and say solution, you write the formula. EP is equal to mgh. You get a mark to write the correct formula. What is the mass? The mass should be in kg. So you just come here and say 300 divided by 1000. And then this is going to be 0.3 kg. And then when there is mass, you put 0.3. And then what is G? It's 9.8. And then what is a height? It's 2. You see, you get a mark for that. I hope we're clear on that one. See? And then we take our calculators, we say 0.3 multiplied by 9.8 multiplied by 2. What is the answer that we are getting? A beautiful 5.88 joules. That's another mark. See? That is how to calculate to determine the gravitational potential energy of 300-gram ball. See? All right, let's continue. If you want to copy, you can pause the video and copy, then you continue. All right. That is the question which relate to the gravitational potential energy. Gravitational potential energy. All right, that is good. Okay. Now, let's see what we are having here. Let's talk about the other example. Let me give you another example. Let me say, determine the kinetic determine the kinetic energy of a 250-gram ball when it is moving, when it is moving with a velocity of 2,5, or rather, let me say of maybe it's moving at 4 meters per second. That is the question that we're having. So since it's kinetic energy, don't forget, you write EK, now this is EK, is equal to 1 over 2 mv squared. Then you say 1 over 2, what is the mass? Oh, it's in grams. So you're going to say 250 over 1000 is going to be 0,25. That is what we are having. You replace 0,25. Now, what is the velocity? It's 4. So where there is v, you put 4, and then you square it. And then from this information that we're having, we press our calculator. See, we press our calculator, 0,25 times that one. And then the answer is 2 joules. That is what we are having. I hope it's clear there. I hope you are getting it. Right? That's wonderful. Okay. Now I think we can move on. Let's try to move on so that we see how far we can go, because I'm intending to finish this topic here. We need to understand what is it that is taking place so that you can be able to calculate. Now, the next thing I want to talk about mechanical energy. Mechanical energy. Mechanical energy. What is this when we talk about mechanical energy? It refers to the sum of gravitational potential energy. Sum of gravitational potential energy and kinetic energy. That is the thing at what? At a point. The sum of gravitational potential energy and mechanical energy. Let's write it mathematical so that you can see what I mean. I will call it EM, which is mechanical energy. The sum of EP, see, you said gravitational, plus E what? EK. You can simply expand this since you know that EP, you can say mgh EP plus 1 over 2 mv squared. So this is the formula for mechanical energy. What is mechanical energy, guys? Is the sum of gravitational potential energy and kinetic energy at a point. That is what we have, you see. Now, I can just pick one example so that you see what is happening. I can pick one example so that you see what is happening. Okay, let me just give this one as an example. And then we say a ball of mass 4 kg is thrown on the air on the air and the ball travel at 3 meter per second 3 meter per second and move and cover the height of 6 meters. This is the information that we are given. Okay, now look at this one. Determine the mechanical energy. Determine the mechanical energy of the ball. 4 marks. See, these are very easy questions that you need to look at. All right. So, which simply means that you're going to say EM is equal to EP plus EK. That is the solution. EP, and then what is, you expand mgh plus 1 over 2 mv squared. And then what is the mass? It's 4 kg. So you put 4 here. G 9,8. H, what is the height? It's 6. It's given. 1 over 2. What is the mass? You can see the mass. It's what is the mass? It's 4 kg. You see, velocity is 3 squared. You see, now with this information, it become easy for you to get the answer. So how do you get this answer? You are going to replace with 4, 9,8, and then the height is 6. Then you say plus, and then you're going to get 4. And then you replace with what? With 3. Then you square it. So the answer is going to be 253,2 joules. That is the mechanical energy of the ball. So you should be able to read this thing and know that if you are given the height, where do you replace it to? You see? Okay. I think it's easy when you do it like that. I think it's easy when you do it like that. All right. So which one can we look at now? I think now let's go straight to this other one. Let's talk about principle of conservation of mechanical energy. That is the last part. It's called principle of conservation of mechanical energy. All right, we want to look at the principle now. And then what is happening, guys? Let's try to define it. This is very important and it's examinable. It states that it states that it states that the total mechanical the total mechanical energy in an isolated system, the total mechanical energy in an isolated system remains constant. That is the thing. That is the definition or the principle. It's very, very important. You should know this one. Okay. Now, let's go straight to the formula. The formula says E mechanical energy at point A is equal to E mech, the mechanical energy at point B. Others they can say after and before. You see? But nevertheless, what you need to know at rest, let me give you some key points. At rest, velocity is equal to 0. Don't forget about that. At rest, even like stationary, something stationary, velocity is equal to what? Is equal to 0. So in most cases, at the ground, this is the ground. At the ground, height is equal to 0 at the ground. If it's a ground, height is equal to 0. And remember, it means EP will be equal to 0 joule. Now, at the maximum height, that's when EK is equal to 0 at the maximum what? Height, when it is stopped. At maximum what? Height. The EK will be equal to 0. Right? Let's try to see if we can get something here. You're going to calculate several things, your speed and so forth. Okay, let's have this one as an example. E.g., we are having an edge here up until like this, going down. And then this is ball A, is at rest. This ball is at rest. And then this ball is 5 kg, it's at rest. You see? And then what is it that happened? It move here downwards. And then this is point B. It reached here. Remember, the ball is still 5 kg. And then this height, it's 10 meters. I want you to see something. Now, the question I can have is calculate the velocity of the ball. Calculate the velocity of the ball at what? At B. 4 marks. See? Now, if you check this thing, guys, at rest, meaning velocity here, it's 0. Here, we are looking for the velocity at B, and we don't know. You see? But since here it's on the ground, we know that here H is 0, but here H is 10. You see? So let's get the formula. We're going to say Emax at A is equal to Emax at B. Now we expand the formula. It will be mgh at A plus 1 over 2 mv squared at A is equal to mgh at B plus 1 over 2 mv squared at B. Right? This is what you are supposed to do. You are applying the conservation of mechanical energy. What is the mass of the ball? It's 5. Okay, what is G? It's 9,8. What is the height at A? It's 10. You can see there, it's 10. Plus 1 over 2. What is the mass? It's 5. What is the velocity at A? Check, guys. What is the velocity? It's 0 because it's at rest. You see? It's equal to 5 times 9,8. What is the height at B? It's 0 because it's down there on the floor. 1 plus 1 over 2 into 5 V squared B. We are good. That's what we are looking for. Okay, so what are we going to do here, learners? What are we going to do here now? We're going to calculate. We're going to say 5 multiplied by 9,8 multiplied by 10. What is the answer? This side, I'm getting 490 plus 0. Do you know why 0? If you press this in your calculator, you're going to get 0. It's equal to, if you press this one in your calculator, you're going to get 0. See? Then you say plus. This one will be 2,5 V squared B. That's what we are having. I hope it's clear. Okay? All right. So now, what are we having, guys? We're having 2,5 V squared B. I'm just copying it like this. For what? 490. You divide both sides by 2,5. 2,5. So 490 divided by 490 divided by 2,5. I see 196. So VB squared is equal to 196. Look at this, Vananga. How do you remove a squared? So VB is equal to square root of 196. So what is the square root of 196? You all agree that it's 14. So the answer will be 14 meter per second. 4 marks. I hope it's clear. That is how we should do it, guys. That's how it should be done. And it looks like it's difficult, but it is not difficult. That's a small water. Okay. All right. Let me let me try to get another example so that you see how it is done on this lesson. Okay. Let's have this one an example. I will say a 2 kg ball, a 2 kg ball rolls from A at 3 meters per second. Okay. Now the question is determine the maximum height. Maximum height the ball will reach at B. That is the thing. Let me show you what is happening. We are having a flow like this and then it go up like this. Okay. This is what is happening. This is point A. That is the ball, which is 2 kg. It is rolling at what? At 3 meter per second. And then it come here and reach the maximum height. This is B. It's a maximum height at B. You see, the 2 kg block is going this side. So we want to know as this ball was coming from this side moving, where will it reach? You see, right? How do we do it? Emac again. You started there. Emac at A is equal to Emac at B. You say mgh plus 1 over 2 mv squared is equal to mgh plus 1 over 2 mv squared. Now, what is the mass? It's 2. G is 9,8. What is the height at A? It's 0. Here it's 0 at A, the height. It's on the floor. Plus 1 over 2, 2. What is the velocity? Is 3. Okay. What is the mass? Is 2g, 9,8. What is the height at B? That's what we are looking for. This side is for B. Okay. Plus 1 over 2 mass, it's 2. What is the velocity at the maximum height? It's 0. Don't forget. Velocity at the maximum height, it's 0. So, which simply means that the answer that we're going to get on the left, it will be 9 because here it will be 0 plus 9. Okay, let me just show it here properly so that you see. It will be 0 plus 9. It's equal to, here is going to be 19.6 HB plus 0. So we are going to get 19.6 HB is equal to 9. Therefore, divide here. How do you solve this? Divide by 19.6 both sides. You see? How are you going to do it? You will say 9. You are going to say 9 divided by 19.6. So you are going to get 0,46 meters. You see? That is how you answer these questions using the conservation of mechanical energy. Conservation of mechanical energy. All right, go through this videos, learners. This video, I'm going to send you activities immediately after listening to this video. You will react and then we go and look at the past questions. Thank you. All the best as we prepare for your final examination.